Section 3.5, inverse function. So in this section, we are going to understand the definition. What is a one-to-one? Determine whether the function is one-to-one. Verify inverse function. How to find the inverse function. And graph the relationship between the function f and the inverse function f of -1. So we start from what is one-to-one. So one-to-one functions are functions whose inverse are also the function. So if we look at a graph here first, one-to-one, I mean this is a domain, this is a range. So for each domain, it will assign a particular y value or particular range value. So R assigned to 3, B assigned to 7, M assigned to 1, and N assigned to 9. So each element inside of the domain has received a particular range value. So in that case, this is a 1-to-1. If you look at this graph, R assigned to 3, B also assigned to 3, so that means R and B, they are shared the same number 3 on the range. So in that case, this is not a 1-to-1. So the definition of the 1-to-1, it must be each element on the domain has assigned to a particular value on the y. So now we go back to look at the definition here. One-to-one function, they are functions whose inverse are also the function. Alright, so if you get confused about this part, when we finish the section, you will understand what does that mean. We look at the example of this one. Each student, their correspondence exactly one eye color. This is not possible because eye color, this is very easy to have two students share. Two students has the same eye color, right? So this won't be a one-to-one function because two students can have the same eye color. To each student, their correspondence exactly one college ID number. So this is a one-to-one because two students will always has two different ID number. So that means, in other words, no two students will share the same ID. So in that case, this is a one-to-one, but not this one. We know that element x in the domain of the function has a single output y. For some functions, different number x in the domain can have the same output. So if you look at the graph of this one, on the y value here, this is a y. So these 3 points on the graph here, they share the same y value. This is a function, alright, because it passed through the vertical line test. So this is a function. Function, yes. It's a one-to-one. One-to-one. No, this is not one-to-one because 3 different x values share the same y value. In that case, this is not a one-to-one. So here give us another definition. We will do this one. A function f from a set x to a set y is called a one-to-one function if and only if different number in the domain of x have different output in the range y. So this is a better definition of the one-to-one. Now, how can we determine whether the function is one-to-one? Horizontal line test, or we can do the test. All right, for example, this function has x power 4 plus x power 2. So I'm going to try, for example, 2. So when I have the 2 substitute into the function, I get a 2 to the power 4 plus 2 to the power 2. So 2 to the power 4 is 16 plus 4, which is 20. Now we tried x equal negative 2. So negative 2, plug in here, you'll get a positive value as well. So it has 20. So that means 2 different input or 2 different value on the domain share the same y value. So in that case, this is not a one-to-one function. Or if you sketch the graph, x power 4 plus x power 2, x power 4 plus x power 2, it has a parabola facing up for both. So this is x power 2, this is x power 4. When I draw the horizontal line test, determine the one-to-one function, we use the horizontal line test. So when the line passing through the graph more than one point, then in that case, it's not a one-to-one. Now we try part B. This is a cube function, right? So I'm going to use the same number, f of 2, plug into the function is 8. F of negative 2, plug into the function, it gives me the negative 8. So different input getting the different output. In that case, yes, this is a one-to-one. If you sketch the graph of the cube function, drawing the horizontal line test, so the horizontal line only passing through the graph one point at a time. So in that case, yes, this is a one-to-one. I hope that makes sense too. A horizontal line test can be used to determine whether the graph of a function represents a one-to-one function. So when the question gives you the graph, you just simply to draw the horizontal line to passing through the graph. When the line only passing through the graph one point at a time, so you can say that is a one-to-one. When the question gives you the equation, the function equation, you can pick a positive value and also pick the negative value with the same number and pick the small number. Plug in into the function and see whether you can get the same result for both. If that is the case, you have negative x value and the positive x value get the same y value. In that case, not a one-to-one. But when you have the different x value receiving the different y value, then in that case, yes, this is a one-to-one. So it could be graphically or equationally. So if you give it equation, you just substitute a number into it. If not, when they give it a graph, just draw the horizontal line test. So if you look at this graph, the horizontal line test passing through 3 points at a time with the horizontal line. So in that case, this is not a one-to-one. Verify the inverse. When function is a one-to-one, then we can define this is the inverse notation, because this is a function notation, right? This is a function of f of x. So when you see the power, degree power part has a negative 1 on it, this is the inverse. And this is a function. So when you have the inverse function composed with the function itself, it will go back to the single x. The other way around, when you have the function composed with the inverse function, the output is x. So when you have both conditions satisfied, in that case, these two functions, they are inverse to each other. So that means the f function is a one-to-one function. and that the inverse of that function that is a one-to-one function as well. So we look at the example. Verify whether these two functions are inverse or not. So we do f compose g. Okay, the idea is, well, f compose g at that point x, when we can get an x, or g compose f at that point x, we get an output is x. Once we can prove the output for both of the compose get an x, that means these two functions they are inverse to each other. So we do this way. F of g of x, right? So I start to rewrite, I let the f function stay outside, and I start to compose g function. Now, g function has cubic root of x. Now go find the f function. F function is x power 3. So when I hear the x, I leave it blank, power 3. Now I substitute the root 3x into here. So root 3x. Now the root 3 cancels out with the power 3, so it turns to a single x. This is what we want. We do the other way around. G compose f, so g stay outside, f function inside. So we start from f function is x power 3. And your outside still has that g function. Now we substitute the g function into here. So it's a cubic root of x. So x, I leave it blank. Now I'm going to replace the blank with x power 3. This power 3 will cancel out with index number 3 here. So it turns to the x as well. So once you can prove both of the function when they compose to two-way direction, right? F compose g and g compose f, both of the result give us the single x. In that case, yes, your f function and the g function, they are inverse.